My name is Chet Corcos, and this is the first video in a series where I will be interviewing experienced programmers about how they build software. Today I'm talking to Toby Schachman. Toby's built a bunch of really creative and interesting software projects, all of which have some powerful visual programming interactions. And today we're talking about his latest project called Cuttle.xyz. Cuttle is a tool for digital cutting machines like CNC routers and laser cutters, and it allows you to construct shapes into components and compose them together. And it's a really simple yet powerful interface with a whole scripting API, so you can create your own modifiers and transformations. And I've been following Cuttle since the very beginning, and every time Toby sends out an email update, I just wonder to myself, how the heck did he build this thing? And so me and Toby have been going back and forth on email for a while now, and we sort of came up with this whole idea for an interview format where we're actually going to be looking at code, and it'll be a little bit more technical and in the weeds with things. And in this interview, I really enjoyed not just the technical details, but the little glimpses of just how Toby works. I noticed he's really tactile with the mouse. He doesn't really use keyboard shortcuts. He didn't use search a single time. He mostly just browsed through his files and clicked around. And it kind of makes me chuckle, because a lot of people think that you have to be some kind of Vim wizard to be a good programmer. And that's just clearly not true. Even things like his build system is pretty much, an off-the-shelf thing. It's not this like overly constructed, some master programmer has some crazy setup that no one knows about. It's kind of quite the opposite. He's like, I don't really care about that, just moving on. And then a couple things too that made me really chuckle is how he's using eval all over the place, which is kind of breaking the rules. Everyone always says that eval is insecure and it's not fast, but he built his own sort of JavaScript dialect where he's parsing things. He's got operator overloads and does all this like logging to kind of map the code into the interface. It's all really quite interesting, and so yeah, I hope you enjoy this interview as much as I did, and always curious to hear what other kind of details you guys pick up on. So enjoy.
So I guess like maybe before we get into the code, I was thinking of just giving like a really brief like what can this do. So you already mentioned like the use cases for making cut out shapes using digital cutters. The way that it works is it's sort of essentially like a sort of a Bezier editor that's combined with sort of a programming element. And the idea is that you should be able to switch between thinking visually and thinking programmatically, and like go back and forth quickly between those different modes of thinking. So you can draw something, but then you have a bunch of these like modifiers. The modifiers can change the thing that you drew. You can go back and edit the thing you drew, and then it changes everywhere. You can combine.
Can you click on
the modifiers?
Things? Or are you okay?
Yeah,
that's like your main one. Okay.
So this is a path. I'll turn off the modifiers. So that's just a path. It's made up of anchors that each have positions and handles. You can move them around, and then you can add on these modifiers. The modifiers are themselves written in JavaScript. So you can sort of fork the built-in modifiers or write your own modifiers.
Cool.
And then, you can then make your shapes with that. And so the idea is that the modifiers give you like non-destructive editing, but then also you can start using sort of more programmatic kinds of ideas in there.
Yeah. Well, I already have tons of questions.
Yeah, I mean, like, do you want to just go into questions? and then I can show more features as you're asking questions. Because this is just the beginning.
Yeah. If maybe we can, I would say maybe just show a couple more things if
Okay.
you want to give
Yeah.
a whole overview here.
So the thing that you're making is a component. A component is essentially like a function. You can drag out sort of more instances of the components. The components can have parameters. So this one's P1, I'll set it to 4, and then in the rotational repeat, I'll set the repetitions to P1, and then I can change P1 and it changes the number of repetitions. But then each instance, I can modify the parameter for it. So you can think of this as a function. Each of these are like essentially named parameters. I could use P1 to set like the stroke width also or something, just to have something else happening. And then, it'll be doing that.
Yeah, very cool.
Everything is like in place editing. So I can like double click this component and then double click this path. And then I'm like changing this, but everything changes live. So the idea is that that's what makes it easier to, I think I don't like this times P1 there. That's what makes it easier to sort of jump back and forth between the thinking visually kind of and the like programming.
Yeah, the component model. Yeah, that's very cool. You can like that encapsulation doesn't limit you in the user interface.
Right. Yeah, you don't have to go in here because you often want to be editing a component in context.
Yeah. Very cool.
The whole thing is implemented in itself. So like a polygon, for example, is itself a component. There's this show contents thing that pops it open. And so the polygon is itself a So it has a number of sides. So I'll say like 7 sides, and then it's a path with a single anchor that has a rotational repeat that has sides repetitions. So so all of these built-in things are themselves components. This one is I think just implemented with code. So you can make components that you draw on the canvas, or you can make components that are code components where you can just type in code and it makes the thing, and these can have parameters.
Cool. So like that arc, let's see, console geometry, start angle. So like what's your output? Okay, return path from arc. Okay. Oh, yeah. Like constructing a Bezier curve, basically. Bezier?
Yeah, so everything ends up being Bezier curves. So there's this function path from arc. Let's see. So there's the scripting documentation. So you can make a path. Path is essentially Bezier curve, but then you can construct their various sort of convenient methods for constructing them. So like an arc, and it makes I guess an approximate arc, because you can't have a perfect arc with cubic Beziers. But anyway,
very cool.
Yeah. And then the other cool thing is that these parameters, because they're themselves vectors, they can be moved around on the canvas. So, right, like this parameter was just a number, so doesn't really give you like canvas access to it. But if you had a like
a vector, right?
Yeah, so if this was like a vec, and then here I was like P1 dot length. So then I'm getting a number out of it, and then I can like move this around and I guess the distance from here to here is determining how many repetitions it has.
Yeah, that's very cool.
And then, oh, so I had overridden P1 to be a number here. So it's like, that's causing an error. But if I do that, then I've got my thing there and here also. So yeah, you can have parameters that are vectors and then they show up on the canvas.
And you have a continuous amount of repetitions there now, like a fractional amount potentially. Right?
Yeah. And I guess that works because the rotational repeat just has like a for loop here. So even if repetitions is a fraction, it floors it essentially.
Yeah. That makes sense, but it's still kind of, you get that.
Right, because it's using that number as the angle.
Sure.
Like 360 divided by that number.
That's really cool. Man, this program is so cool. I'm sorry, this is just so exciting for me. So yeah, I mean, I guess this is probably a good point to maybe dive into the code a little bit. I was thinking, basically, you could kind of walk us through your code and more or less onboard me as if I'm like a new employee, and we could kind of go back and forth, ask a bunch of questions, and sort of go from there.
Okay. Sound? Yeah.
Also, more things you want to kind of highlight in terms of overview.
Yeah, I'm just thinking like, so I feel like the main thing that I would want to show you that I think is interesting is like the evaluation model. So essentially, like, this is a program. You can think of it as a program that some of the things are just literals, like these anchors are essentially just literals because they're all just literal values there. And then you've got this path, and then the rotational repeat is like a sort of a function that takes the path and outputs something else, and then the outline stroke does another thing like that. Mm-hmm. We talked about how the components are essentially functions.
Yeah.
The other thing is that you can as these are, because these are functions, you can like sort of call them from code. So so that one's called component A. So like I could say return component A. So that just calls that as a function, but then you can also pass in like the parameters.
Nice.
And then that's useful. I was going to show like this is like a sculpture I've been working on. I don't know if you can see, but there's like it's a bunch of like strips of paper that are interlocking with tabs. There's no glue involved. And sorry, say again.
You put a light bulb in there?
Yeah, it's going to be a lampshade. And like it's really cool that like I'm able to iterate on that by like, making a component for all like the tabs, and the pedals and the interlocking tabs, using linear repeat to make a bunch of those, mm-hmm. Visualizing what they would look like if they're together. So you can see how the tabs are going to interlock with each other. And you can like double click in and like start like modifying those things. So if I'm like, I want to like change how that is, like I can see it in the context of like what I'm working on. Sure. But then I made a component that is able to sort of take the strip and change what the curvature is. So the way that like if the strips are just straight, then it makes a cylinder. Yeah. But if the strips are curved, then it makes a cone-like shape. And these are the radii of like the two parts of the cone And then like once you have that, then you can write code that calls like that radial strip component based on like what I want the profile of the thing to be. So I can change like the profile of the sculpture, and then
And you have to make sure those tabs still line up, right? So there's some like invariant there that's to be maintained, right?
yeah, so I have to make sure that that like here the tabs line up, and then when I'm bending it,
I guess
what ends up happening is that the tabs here get bigger, but then on the next iteration that the bottom tab is bigger. So the tabs always fit. So yeah, each one, like the R1 determines like the curvature of the bottom part. And so that is going to have to be the same as the R2 on the next the one before it, I guess. So they all fit together. Yeah.
Yeah, very cool.
But it's just like I showed you this just because I thought it's interesting that you can be switching between like coding or drawing like easily. And the reason you're able to do that, I think, is because the components are essentially functions.
Yeah, very composable.
But yeah, I could show you like more things, but I think you're right. I think we should look at the code because that's, I think, what we wanted to do with a lot of our time.
Yeah, well, that was a good demo of like, here's a real thing, and like,
yeah,
how sophisticated it can be.
Let me open up Enter. Yeah, I mean, did you want to? I think when you mentioned this to me, you're like, oh yeah, we should like start by like npm run kind of everything. Like, do you want to do that? Like, or you tell me the next step.
Yeah, I mean, I think it does help to give people a sense of things if you start from like the very beginning. I mean, we could go through these things pretty quickly, but then people could say, oh, you're using like Webpack, or you're not, or like like he's not using anything that I read on the internet, and like
cool. Okay, yeah. So this is the editor repo, and it's essentially the just this part of the application. There's also like a dashboard and user management and all that kind of stuff, and that's actually in a separate repo. Okay. But we have the editor just as a standalone thing that we're able to run locally, and that makes it easier to iterate. And so, yeah, so we have this run dev thing. It's running Snowpack, which is like Webpack or Vite, or there are a bunch of these like building things. I think we'll probably switch out Snowpack for Vite because I think Vite is being maintained, and the Snowpack people were saying you should migrate to Vite. So we'll do that at some point. Cool. But it just like takes TypeScript and makes it into JavaScript and gets all your npm things. So like, yeah, we have dependencies on like CodeMirror, for example. So the Snowpack will make that happen for us.
Cool. So are you using like so you aren't using any like crazy pre-processing things, or just whatever's bundled with it? Like, what do you do for CSS, for example, or is it all kind of inline?
Yeah, we're using less, which I don't really like but we'll probably switch it out at some point, but it's a thing.
Mhm.
So we have a bunch of these files, and then Snowpack is able to sort of make those happen, and then you can still like you can make your I don't know, trying to find like a thing to change. It refreshes instantly, which I
Okay.
like. Because when I'm doing CSS, like it needs to be instant because I'm like tweaking a bunch of stuff.
Yeah, of course.
Yeah, CSS is not as well architected as a lot of the rest of the code, in my opinion. I think I want to switch that out for something more modular.
Sure.
And then let's see. So there's like the geometry library is essentially everything that's implemented here. So like you have vex that you can multiply and add and do a dot product, and segments and paths and groups and things like that, colors. So all of that is like the, I guess, userland scripting, all the things that you can put into a code component or modifier.
Yeah, so those are like the primitive shapes.
Uh, yes, but not these.
Yeah,
These are built-in components, but the primitive shapes being like path and
Yeah.
anchor.
Cool.
Yeah. So that's its own library. Or we want to eventually spin that out into its own library. So we try to keep that separate from the rest of the code.
Yeah.
So yeah, it's just a bunch of
PathKit. What's PathKit?
PathKit is a thing that Skia puts out, and it does Boolean operations and like stroke operations.
So that's how you do things like take a stroke and then widen it into an outline. I see.
Yeah. Or even just doing like that. It's sort of non-trivial code to do that. And so we're just leveraging this existing package for doing that. We'll probably eventually switch it out for our own implementations, but it was a great way to get started.
Oh yeah, for sure.
And it works pretty well.
Mhm. And then I guess, kind of are you using React, or how does
Oh, right. And then we're using Mithril, which is like React, but a little bit more minimal.
Okay.
So that's in this view area. I think this is like the components sidebar. And you end up with, you make like a Mithril component, and you can call other components. So then there's another Mithril component, and you can have sort of on-click handlers and things like that.
Cool. So yeah, it's like I think there's something called hyperscript. It's just sort of
Yeah, that's like the syntax for it. I suppose we could use JSX. Is that what the React sort of built-in thing? But yeah, it's the same thing. Yeah, you
wouldn't get the convenience of these like adding class names like that. Like you can add arbitrary selectors, I'm sure, right? Like CSS selectors, like dot component category.
Right. Yeah. So this is like a div with the class component category. Yeah. So yeah, so we use that, and that sort of generates the DOM stuff. The canvas right now is implemented with SVG, but we ended up sort of doing our own sort of thing in there. Let's see. Like the canvas UI, or like maybe the transform box. So it's like it has to have the corner resize handles and the rotation handles and things like that. And these are all just implemented as these classes. So we sort of make our own, it's like we make our own virtual DOM that is the canvas, and then that gets turned into SVG, which we're probably going to be swapping out with either Canvas 2D or WebGL or something. But we started with SVG, then we realized we needed to make our own implementation because we wanted like our custom hit testing essentially.
Yeah. I mean, there's something elegant about SVG because, you know, it's baked into the browser and everything. But the thing that has always kind of been interesting challenge for me to think about is like, you know, when you're using SVG, you want to say like, oh, this, you know, when I'm within, you know, pixels of the corner, like I should kind of, you know,
right. Yeah, exactly.
help you out there. And so like, are you just, are you creating some like invisible border around these different control points, or are you like watching mouse move and calculating your closest?
Right. So before we were just making like, so this is only 1 pixel or whatever, but we wanted the hit area to be slightly bigger.
Yeah.
And so we were just making a bigger stroke, but then what we wanted is here, we wanted it to be whichever one's closer. And so you can't do that with just having a bunch of invisible SVGs.
Yeah, totally.
So at that point we realized, oh, we need to have custom hit logic. And so that's why we're making sort of our own, like the canvas turns into its own little virtual DOM, and then we're able to, given a mouse position, essentially decide what is hit from that using our own logic.
Yeah. Wow, that sounds complicated.
A lot of the most complicated part is just like, you know, figuring out what is the distance from my mouse to this path, and what is the point that's closest on the path to the mouse position. But we had to implement all those geometry routines anyway for the geometry library. So we already had a really rich geometry library.
Yeah.
So that made at least the geometry part of it easier.
Yeah. So I'm assuming in some, you know, deep dark corner of like Bezier curve documentation, there's like math that just tells you that. Because I mean, that's pretty complicated. You have control points, right?
Yeah. So path has I think all graphics have or all geometry things have this closest point. And so you pass in a point and optionally an area of interest, which is an optimization to like not look too far away. And then it finds the closest point. So yeah, this is a lot of math to do that.
It's not like a sampling though. I mean, it's a closed form kind of math.
How are we doing it? A sampling isn't the worst idea to do it that way, but I think we have something slightly more sophisticated to do it. Yeah. It's definitely like, not sure where the code for this lives. Yeah, I think it's this stuff. So, you know, we found some paper from 1995, and it talks about this, and it's yeah, I don't think I could walk you through this because this isn't my code, but yeah, you can find roots of various sizes up to like maybe 4 or 5 degree polynomials, and then you've got that as sort of a closed form thing, but there are gazillion edge cases, and yeah, I don't remember how this algorithm works. Ryan put this together. but could read about it.
No, that's good to know. Cool.
Yeah.
All right, yeah. Where do you want to go next? We could, yeah. I think the evaluation engine obviously is probably
Evaluation. Okay.
yeah. And I guess when you say these things are I mean, at a high level, I totally get it.
Mhm.
You got these programs and these functions and compose, but like,
Mhm.
then there's like what they literally are in your code. Like,
Yeah.
how do you have a function that is a function, and there's some definition of like, oh, it has arguments and return values, and then like run like eval something, or
Right. Yeah. So there are a bunch of things. Let's see. I wonder what the best place to like start into it is. Well, maybe I'll start. I'll work from the top down, but we can also go from the bottom up if you ever want to like talk about, well, how exactly is an expression evaluated? Like,
Sure.
but I'll start from the top down. So your project is a bunch of definitions, component definitions, and then each of those may contain sort of like a hierarchy of shapes, and the shapes can have modifiers on them, including the transform is itself a modifier. Transform just does a transform on its input.
Just to clarify, we have
Yeah.
project, which is a list of component definitions, and each component has a list of shapes, and shapes have modifiers.
Yeah. Yeah, I think that's right. And then the project also contains your custom modifiers if you've written any.
Yeah.
And like a code component just has code. It doesn't have like children. It's essentially just one giant expression. So they're little edge cases, and we're still massaging sort of what the data model should be. But sure, like I think what you summarized is a good place to start.
Mm-hmm.
And so all of that stuff is in this model directory, and don't need to see that. So yeah, like this is the project class. It's got a gazillion methods in it, but yeah, it's got sort of some settings, like what units are you using. Then yeah, a list of all your components.
Okay.
And a list of all your custom modifiers, the README, some state about like what you're looking at and what your selection is.
Mm-hmm.
This is state about like which things are expanded in the outline. There's some really horrible names like node and instance. These are just really bad names because we couldn't.
Yeah.
We should change a lot of names here. I'll try to use the names from how I think about it in Cuttle rather than anyway. I'm sure you'll see a lot of bad code in your series.
Kind of an aside here,
yeah,
briefly, which is like this all gets serialized, right? So,
oh yeah, that's a good thing to point out. Exactly, yeah. So the whole thing needs to be serialized so that we can reload a project.
Mm-hmm.
And the way we're doing that is it's essentially so because the project can have like loops, it's not just a tree, it's mostly a tree, but there is like a graph element to it because like when you have this thing is a shape that points to the definition component A, and that's a direct link. So there's some loops in our thing. So it's not, we can't just tree it, but we use sort of a convention / standard called JSOG, which is like JSON, but with graphs.
Okay.
You can look it up. It's essentially what it does is it makes you like JSON stuff, but then if it sees a reference that it's already seen before, it makes a thing that it's just like ID equals 3 or something, and it calls that thing 3. And so then it's able, when it deserializes, it's able to create the graph again.
Yeah, that makes sense.
So so yeah, it's sort of like that.
And this is very general. You're just enumerating through whatever keys, right? So there aren't, I guess, you can't have any like things on that are like not getting serialized on that project.
Yeah, unless we explicitly make an exception for it, which we're sort of doing, I think.
Okay.
Yeah, this is sort of just evolved, I guess. However, it's evolved. I think we can look at. So this is the editor here, and then so if you're just running the editor locally, we keep the I'm able to refresh, and I still have my project because we're just storing it in local storage. So you can see what the
what it looks like.
Yeah. So this is like what gets serialized. So there's sort of like a header. There's a version because every time we need to like migrate everyone because we've changed something drastic about the model, then we're able to say, oh, if you're version 25, we're on version 26 now. To get from 25 to 26, do this, run this code on the payload first. And so you get that, right?
That's also a pretty painful thing to deal with in my experience. Are you just like, because like ideally you'd have like all 25 sets of types. And so like your migration functions can like upgrade every time, and then you have some confidence. But what ends up happening is you just have the latest type and you just like cast to any and you're like, I wrote some tests, I swear it works.
Yeah, that's sort of, yeah. So the serialized stuff is not type checked. And so it's just like, we hope that it works. And then, yeah, all of the versioning stuff.
Oh yeah.
So it's like, if the version's 9, then we did this thing. And so we'll just make a little change to it. These are all supposed to have comments. I don't know why some of them don't. Yeah, it's like we changed how like fill and stroke worked. So this is how you do it now, sort of stuff like that.
Very cool. And so I guess, so when you edit this document and you save it in, I don't know, Firebase or whatever you're using, like you just, new JSON, like boom, and you have, some sort of like a debounce kind of throttle.
Yes.
Cool.
Yeah.
That's pretty simple.
Yeah. I think, we'll eventually want to have multiplayer and stuff like that and be sending diffs and that whole thing, but we haven't done that yet.
Yeah, that'll be pretty intense, I'm sure.
Mm-hmm. Cool. Yeah.
All right, I guess like let's pop the stack a little bit. What were we talking about? Oh, the project. That's kind of where we were.
So here's the project, and then I guess this is a component. It has like a root level shape, which we call elements, which is a horrible name. But it's essentially like the group at the top of the so like this component has a path, a circle, and a rectangle, but it also has like a root level element shape out here that you can't see that has all of these as its children.
Sure.
So that's, and then these things, each one of these is essentially an item in your outline.
Okay.
An element. I've been calling them shapes. I think it's a better name. So we'll probably change the name. But each one of these is an element, and an element can have a name. It has which it has like sort of a reference to like the thing that it is, right? So this thing has to know that it's a circle. This thing has to know that it's a rectangle. this thing has to know that it's a polygon that has a number of sides that you can change.
Cool. Yeah.
So like each one of these things we call an instance, which is also a horrible name, but that's what we're calling it. And
That's
in the code,
of the modifier, right?
it's an instance of a modifier. Is that
Yeah.
what you said? Yeah. So each one of these things is an instance. So there's the base instance, which is like what you start with, and then a series of modifiers. So the
Okay.
base instance and then a series of modifiers, and the transform, fill, and stroke are we separate those out, but they're essentially, it's like a series of modifiers. And the thing can have, some of the things can have children.
Cool.
Yeah.
And then valid material keys. So this is like, maybe how you, so I guess when you modify this user interface, like one of these objects, are you just doing a full re-render basically? Like,
yeah, so we started by doing a full re-render, a full reevaluation and re-render. So I mean, like React does a full re-render like every in the sense that it generates the entire virtual DOM and then it does something clever at that point. So we're definitely generating the whole virtual DOM, but also the evaluation used to be a full re-evaluation every time. And then recently we added memoization so that it's still conceptually a full reevaluation, but it's able to use work that it did in the previous evaluation.
Sure. Yeah, that makes sense.
Yeah, so that's sort of the model. This stuff is this is like sort of stuff that the memoizer uses to know if like there was something that changed, that the evaluation would change. So like if you change the name of a thing, it won't affect the evaluation. So that's not in here. And then this is part of the undo system. These are like the things that if they get changed, it needs to sort of make a new undo state.
Yeah. So I guess in this model, at least, you're saying how like every thing is really just like some code, right? So whether it's like a circle or a square or like I'm curious, like where, like I know like any of these little things, like your transform here, you click like some like edit button somewhere, and it just here's the code for that thing, and you can change it, right?
Yeah. Let's see, it's not showing me that because it's not letting me edit the. Yeah.
Oh,
I feel like it should let me see the code. I'm not sure why it isn't. For like how a transform works.
Yeah,
I thought we were looking at that.
Maybe it's because that's from like a primitive shape. I don't know now.
I'm not. I usually don't look at like that. So it's like I have this and then I move it. Yeah, why doesn't it let me see the?
I think it's because it's the base one. I think if you create a transform, like if you go to modify and then add a transform.
Except it's not in this menu.
But add like a transform repeat, let's say.
Oh yeah. Any of these are you can see, but like the transform itself has code.
Oh.
And I don't know why it's.
Hey, it's.
Oh, I can create a variation and then it'll let me see the code.
Okay.
So if I want to change what transform does, I guess I can do that.
So when you have like, for example, when you have a transform, okay, and it's an instance or whatever arbitrary word we have for it, it's going to have something that says like it's got this position, it's got these parameters.
Yeah.
Here are the instantiated parameters, but then it's also got like here's the code that's running, like it's saying like. So I'm curious.
Yeah, we should look at that, I think. So like an instance has a definition, which is going to be either a component or a modifier, or a code component, I guess. It's it's sort of like anything that can be like here.
Yeah.
Yeah, like mhm.
So my question is kind of like, where is that code? Like,
Yeah.
where is that? Is that just like where's it saved?
So then, yeah, so like there's like the built-in components, or like let's like maybe built-in modifiers. Like these are just hard coded in. It's like a new modifier. It's got some parameters. It's got some code.
I see.
If you make a custom modifier, then it would, this code is in this guy's.
Yeah. So I guess expression is the like lowest level.
Yeah, expression's the lowest level thing.
Okay. A modifier is going to have an expression somewhere in it.
Yes, exactly. And then an expression essentially just has JavaScript code. This is like as you're typing, like sometimes we're not evaluating it, so it's like pre-committed code.
Yeah.
But yeah, this is the code that gets evaluated.
Mhm.
And
But so you're also like kind of swapping out parameter definitions and stuff like that as well, right?
right. So yeah, so now we're at the bottom. So this is the expression. It's got JavaScript code, but we're not running it verbatim. We're doing a few modifications to it. Yeah, I want to show you like what it ends up being. Trying to think about like an easy way to do that. This might blow things up, but let's. I'm just going to log what the compiled version, which is the transformed version. Cool. And that's going to like result in like a lot of log entries, but maybe we'll be able to see something interesting.
Oh wow, yeah.
This is so these are all the things. I'm not doing what I wanted to do though. I want to look at
underscore compiled probably.
Yeah, underscore compiled. I think the easier way to do this is going to be if I just go into compile. So it parses a lot. It like compile takes the code and then gives you like a function that you can actually run. So it's sort of like a val with a function wrapper around the thing. But there's like a bunch of stuff that we do to it that I can talk about. But I just wanted to like see some assembled code. Yeah, maybe this. So yeah. So all right. So there's this use strict whatever. Anything that we're getting from the environment comes in as this like underscore env thing. And that ends up being like passed in as a function.
Sure.
And then we're essentially logging line numbers every time you do something, I think. So this is weird where
I guess
these numbers are strange.
Is that basically just helpful for like kind of debugging, like, oh, it's here's where we're evaluating, like it's like
it's so that when you log something, we can show inline like right underneath it what you ended up with.
Very cool.
I don't know, these numbers make sense, I think.
Maybe there's some fancy like mapping and you kind of modify it into some new thing.
Yeah, I don't remember. Anyway, there's some stuff about that. Whenever you this is something we were talking about before we started recording, you can do vector math just with arithmetic. So
thank God.
So this is some vector, say 2, 1, and then I want to like multiply it by 2, and then I can just do that. And JavaScript doesn't do that, but we have operator overloads, and we implement that by replacing any primitive arithmetic with our custom function.
Nice. Now, okay. So there's something slightly more complicated here, which is like you have a function that returns a vector and you multiply that times 2, right? I guess like to what extent is this like naive versus like, oh, we actually know that this function is returning a vector and therefore we know to substitute an overload.
So basically like this code would get transformed to be _env dot operator overloads dot mul vec2 1 2. Like, so we're replacing this symbol with a function. Okay.
Well, so my question is, okay, in this script, make like a little helper function. It's called like, you know, like some point, and then it returns a vector. And then in the console log, instead of saying vector of 2, 1.
Like if I were to do this.
Yeah, exactly.
It would still work.
Yeah. So you're kind of doing some amount of like type level, you know, inference here to know that like, oh, this variable is a vector, right?
It's all runtime. So like, let's look at the operator overloads for
I see. Every operator, we replace it, and then in the operator overload, it says, oh, if it's a number, then we're just going to do it.
Yeah. So if I add, then I component wise, whatever, and then it's like these things are either numbers or vectors. And then if they're both numbers, it's just normal add, and if they're a number and a vector, then we do this. If they're 2 vectors, then we do that.
Yeah.
So it's all runtime.
That's very cool. Yeah, that's actually fairly generalized too. Like other people could kind of use that effectively to like like a Babel transform or something.
Yeah. And that would be good because JavaScript would be better with operator overloads, I think. So yeah, you can do it yourself. And the way that we're doing that is we're using Acorn, which is an AST parser. So it takes JavaScript code as a string, makes a tree, an AST, abstract syntax tree of the code, and then we just crawl down that and we're looking for multiplication, say, and then we swap that out with some other thing and then turn that back into JavaScript code, and we ended up with all this.
Nice. And then and then are you defining like, you know, vector.prototype, you know, .add and just sort of duck typing that? Or are you basically writing all specific overloads?
No, we're changing what the plus sign means and what the time sign means. We're replacing times with a function and then checking the types in there and doing whatever we want to do.
Cool. Isn't that just an annoying part about TypeScript? You have to cast it to vec, even though you already did that.
I'm not a TypeScript wizard yet, though I've learned a lot. This is the first TypeScript project that I've done.
Oh, cool.
Yeah.
No, I mean, that's kind of just some of the pain that I've had to deal with too. I don't know a better way. But yeah, wow. So, okay. So we have an expression. An expression is sort of your kind of custom JavaScript code, and that will at runtime get compiled into this like
transformed code that's able to reference any
anything in the environment, any like parameters and stuff.
Right. So like this is from a text element. So like the align and the font are coming in from the environment.
Cool.
So yeah, it gets compiled into what you see here. And then this is then, I guess there's a like function wrapper on the outside, function _env that we're not seeing. But then that gets, then we can pass in whatever we want as the _env to get to populate the references correctly.
Yeah. Okay. And so then Okay. What is this? What is this like? I guess you run actually like eval, right? Um, and then
My screen recording just ended up. I'm out of disk space on my screen recording, so maybe we'll swap to yours at this point.
Hopefully it works.
Sorry about that.
No worries. But so this returns something, right? I mean,
Mhm.
and then I guess like an expression is going to return, I don't know, something, and then that's going to go into other expressions, right?
Mhm.
What is it like? What is that kind of? How does that piece together?
The things will get passed in through the environment.
Yeah, I get that, but I just mean more like, you know, there's some function that says like go, and it just sort of
Okay, so now
evaluate, which like recursively.
Okay, so we'll talk about the evaluator now.
Cool.
Yeah. Okay. So this is back sort of at the top level. So to summarize, where we've described like there's this tree of components and elements and instances. The instances have references to modifiers and components. At the bottom level, they're the expressions, which are just the JavaScript code that does this. Now we're going to talk about, so how, if you have something like this, how do you actually do the whole evaluation? And so that's all done with essentially an interpreter. So if you've written like a Lisp interpreter, maybe in your programming class or something, it's that. So generally the way things go, essentially you're like, I'm evaluating a thing and I in some environment. That's sort of the pattern. Sorry, there are two environments here, but it's conceptually, I think it's more like one environment. The idea being that, so if I have like a circle and then I have some P1 and that's changing the scale of the circle, and that might be within some group, and there's other stuff going on. Like it's like, okay, I'm evaluating the circle, but I'm evaluating the circle in this environment where P1 is equal to 4. That's like important. I can't just be like, oh, evaluate the circle, like, because it doesn't know what P1 is. So that's what the environment is. It's essentially a mapping of names to values.
Mm-hmm. Well, and so that expression is going to return, I'm assuming, some of those like primitive,
the geometry primitives.
And then but so now the thing that I'm trying to figure out here is like, are those geometry primitives, they're not really arguments to the next, well, I guess they are kind of arguments to the next level primitive, or like, is it evaluated top down, if that makes sense? I can imagine, for example, if I have a circle and I have a transform, one thing I might do is I might just evaluate the transform, and then, for whatever control points I have, X and Y, I then push those forward.
Yeah, right. I understand. So if you're evaluating an element, the first thing it does is it evaluates like the base part of it, and then that ends up making you the circle. And then it's passing the result of that as the input to a transform modifier, if you have a transform modifier. And then it's passing that to the fill and stroke modifiers, and then passing that to each additional modifier that you have on your thing, and then returning the result of that wrapped in some like debug information.
Cool.
Which we can talk about this. This is interesting too, but continue on your line of questioning.
No, I'd love to talk about the trace too. But to kind of clarify what I was getting at is like, every transform forward is like taking these geometries and modifying them. And so.
I mean, like, so if we wanted to evaluate this, then it would be like, okay, evaluate the group. Okay, group needs to evaluate its children. So then that recursively calls evaluate again.
I
And
see.
then it calls rectangle. Okay, how do you evaluate a rectangle? So first you have to evaluate the base, which is the rectangle itself, which consists of a guide for the center and then a path with 4 anchors. So then, it sort of recursively calls itself, and then like these get evaluated. Those all come up to a path.
Yeah.
This thing then returns a path with
Cool.
4 anchors.
And then so yeah, okay. Now if we put just a simple, we have a transform on there already, right? The 2, 4, x is 2.41, right?
Right. Yeah.
Now,
So
do you apply that transform to so you apply that transform to all the different points, right?
No, these get evaluated, and then the result of that is a path, which is here.
Yeah.
And then the transform runs, and then that moves it over there.
But so when you say it runs, right, the transform is is a script, right? And that script,
Yeah.
Okay.
Takes an input. So the transform takes an input, which is this path, and then it returns another path that's transformed based on whatever these numbers are.
Yeah. Okay. Yeah. This is all fitting together more now. I was thinking about like the transform repeat that you have. You are saying like previous dot clone, and you are actually just returning more geometries. So yeah, that all makes sense. Cool. Well, yeah, let's talk about the traces then. Yeah.
Okay. So
what's our time doing here? We're, I don't know, somewhere close to an hour, I think.
Somewhere close to an hour, I think. Okay, well, we'll talk about the traces. So if all that we wanted to do was get the output, then we could just sort of have these result geometries, and those get passed into the next level, and those get transformed and whatever, and everything goes to the top, and then you get the result geometry and you're done. So that's a typical evaluator. You only care about the result of the function. But we're passing around, instead of getting just the result, we're getting sort of a tree that reflects sort of what you see here. Because we need to show it in the outline potentially. Like we need to show all this stuff, and you need to be able to click here and be able to see like what happened essentially.
Yeah, totally. And
like
then
yeah,
also mapping the guides and stuff back to the
right. Yeah, like the guides need to come up, so that also comes through the trace. Then the guides are not sent through, like modifiers don't apply to guides.
Totally.
Except sort of transform, but we'll ignore that for now. But essentially, like, yeah, you need not just the result, but sort of everything that happened, so that you can display that in the interface. So,
cool. So
yeah.
I think that was a good kind of like overview here.
Okay.
I have so much more understanding of how it works, but also appreciation for like, man, how hard that is to, piece everything together. And, I was kind of thinking about, okay, how do we like sort of close this out? And I guess one question I have for you is like, what's, when you did this project, right? Like what's something that you kind of learned, or like some new ideas that you're like, oh, this is now like, every time I do a red program, I'm doing it this way now. Were there any like kind of big lessons that you learned?
I don't know. It's like this in a series of projects, like starting from like recursive drawing, and then apparatus, and then this, and there's even like a prototype of this before this, and each one, I guess, I learned different things. a lot of the technical stuff, I feel like I already have. Like I've written an interpreter enough times that I know the pattern. It's like, okay, you've got an environment, you've got a thing. The trace idea is pretty cool. That worked out pretty well. And that's like a thing that I guess a lot of that you wouldn't expect to have in if you're just writing an interpreter. But like sort of getting all of the intermediate values all the way up the evaluation, because you're intending to display all of those values to the person using the tool.
Yeah.
That's a sort of a cool idea.
Totally. It's like the SQL explain, which, if you write explain makes it just 1,000 times harder now because, you're writing a program that keeps track of your program, right?
Yeah, it's like keeping track. Yeah, but I mean, like if you think of that as like just part of what you have to do to like, you don't just execute a program, you're also keeping track of all the intermediate results that led you to your final result. Then you have all that stuff and then you realize, oh, it's actually useful to be able to display all those things.
Yeah, totally. Cool. I feel like I had one more question, but I can't recall. Yeah, I guess anything else you want to talk about or
well, I mean, anything else I'd want to talk about, I think would take a long time to talk about, like maybe in a part 2 or something. Because like the memoizer is like pretty interesting, and that's like relatively new code.
Cool. Oh yeah, this was my last question, which is if you don't mind sharing at least, I'm curious, like what is it, what's like on your desk right now? Like what are you currently kind of toying around with in terms of like, okay, you're sitting down to work today, like, I need to get this memoizer to like do something a little differently. Just to give people maybe some insight into like, what is it you're like actually doing, when you're working on this project? Because there's so much, there's so much we just looked at and it's like, oh my gosh, but like, I'm curious kind of to get really narrow, on something.
Well, I mean, right now, like, I feel like a lot of the technical underpinnings are in a good place, other than there's some like testing infrastructure that we really need to do. So most of like what I'm thinking about is how to make this more understandable. So either by making documentation or tutorial videos, or like changing how the interface is presented. Like for example, like the fact that like you can have these components and you can have multiple instances, and then like, why can I like make this bigger and like rotate it? Why doesn't it change that one? But if I double click in and I move that, then it changes those. Like, it's like you get it once you understand like sort of the nesting and how the definitions work. But when you're just starting, that's not obvious. So like just things in the interface to make things like that more obvious are like, those are the kinds of problems that I'm thinking about right now.
Cool. Oh, that's perfect. Well, cool. Yeah. Thanks for doing this. This was really fun. Thanks, Toby. Also.
Thanks, Chet. It was fun.
I hope you guys enjoyed this interview. If you want to learn more about Cuttle, you can visit Cuttle.xyz and sign up and play around with it. It's free for now, so have fun. Also, you could follow Cuttle on Twitter at Cuttle.xyz and learn about all the cool things that people are building with Cuttle. Lastly, if you're building something cool and you think it would be fun to do an architecture walkthrough like this, then feel free to reach out to me. My email is ccorcos@gmail.com, or you can message me on Twitter at ccorcos. Also, it doesn't have to be me doing these interviews. If you enjoy learning about software architecture and want to get really technical like we did in this video, then also feel free to reach out to me and maybe we can work together. Anyways, thanks for watching.